Silverstone has always been Formula One's ultimate aerodynamic test. But under the 2026 regulations, this circuit becomes something completely different. This year, it won't just reward the fastest car, it will reward the smartest engineering package. Let's break down why. At 5.891 kilometers and 52 laps, Silverstone remains one of the fastest circuits on the calendar. It's famous for high-speed corners like Copse, Maggots, and Beckett's, where aerodynamic stability has traditionally been everything. But that's exactly what makes this year so fascinating. Sector 1 starts with Abbey, almost flat out before heavy braking into Village and the Loop. Previously, teams focused on maximising downforce through this section. Now, with around 15 to 30% less overall downforce and much flatter floors, drivers will rely far more on mechanical grip and active aero. Expect engineers to spend the entire weekend chasing front-end confidence without sacrificing straight-line speed. This is where Silverstone separates the great cars from the good ones. Copse, Maggots, Beckett's, Chapel. Every steering input through this sequence changes the car's yaw angle, ride height, and airflow. In previous years, massive ground effect tunnels helped glue the car to the circuit. In 2026, that safety net is gone. Instead, the active front and rear wings constantly switch between low drag and high downforce modes, meaning aerodynamic stability isn't just about producing downforce anymore, it's about managing it. If those aero transitions aren't perfectly calibrated, drivers could experience snap oversteer on entry or understeer mid-corner as airflow separates. This could become one of the biggest performance differentiators of the season. Silverstone also presents a unique power unit challenge. There are relatively few heavy braking zones, so recovering electrical energy becomes much harder than at circuits like Monza or Montreal. That means engineers will carefully balance battery harvesting, deployment, and top speed throughout the lap. Don't be surprised if teams actually sacrifice deployment early in the lap so they can unleash maximum electrical power exiting Chapel and charging down the hangar straight. In 2026, engineers won't optimize individual straights. They'll optimize entire sectors. Another huge change? No traditional DRS. Instead, active aerodynamics work continuously while attacking drivers receive additional electrical deployment when they're close enough to the car ahead. That means overtakes won't be limited to familiar DRS zones anymore. Brooklands, Stowe, even Abbey could all become realistic passing opportunities depending on battery state and energy deployment. Silverstone in 2026 may produce some of the most unpredictable racing we've seen here in years. This weekend isn't about finding the highest downforce setup, it's about finding the most efficient one. Engineers will be chasing stable aero transitions, consistent tyre temperatures, predictable suspension behaviour, efficient battery harvesting, and a car that's stable through Silverstone's relentless high-speed direction changes. Throw in a sprint weekend with just one practice session, plus Silverstone's famously unpredictable wind, and setup decisions become even more critical. Silverstone has always exposed weaknesses in Formula One cars. In 2026, it'll expose weaknesses in entire engineering philosophies. This could be the first circuit that truly shows us which teams have mastered Formula One's biggest technical reset in over a decade. Join me throughout the week for all the coverage.